Hello kids, welcome to my channel. Today we are going to see 7th class science 4th lesson, motion and time. Question answers. Let's start. Improve your learning. First one, state whether the following statements are true or false. Rewrite the wrong statements correctly. A bit, a body can be at rest and in motion at the same time in relation to the same set of surroundings. Answer: a body can be at rest when it is not moving in relation to the set of surroundings. Okay, when it is moving, it cannot be in rest compared to relation to the surroundings. Okay, so when it is body can be at rest when it's not moving in relation to the set of surroundings. B bit, a passenger flying in an aeroplane is at rest with respect to the airport and moving with respect to other passengers. A passenger flying in an aeroplane is at rest with respect to other passengers. Okay, because other passengers will also be flying with him. Okay, so this passenger will be at rest with respect to other passengers. A passenger flying in an aeroplane is moving with respect to the airport. So when airplane is flying, what happens? It will be moving with respect to airport because airport will be at rest position. Okay, it won't move. So when aeroplane moves, what happens? Airplane moves, it will be in motion. Okay, that will be moving with respect to airport. Okay, the wheels of a train are in rotatory motion as well as in translatory motion when it moves. The wheels of a train are in rotatory motion as well as in translatory motion when it moves. Okay, this statement is correct. Next, second one. John tied a stone to a string and whirled it around. What type of motion do you find there? Answer: when a stone is tied to a string and whirled it around, we find rotatory motion in it. Okay, it will be rotating. So it is nothing but rotatory motion. Okay. Next, third one. Identify the motion of the following objects in sewing machine: wheel, needle, cloth. The motion of the wheel is rotatory motion. The wheel will be rotating. In sewing machine, you can see the wheel will be rotating. The motion of the needle is oscillatory motion. Okay, the motion of the needle will be oscillatory motion. Okay. Next, motion of the cloth is translatory motion. Next one. What is common to the following? Motion of the propeller of a flying helicopter, the minute hand of a watch, the tape of cassette recorder. All are examples of translatory motion. All are examples of oscillatory motion. All are examples of rotatory motion. All are examples of periodic motion. Okay, see, minutes and watch, it will be rotating. Propeller of the flying helicopter, it will also be rotating. Okay, the tape of a cassette recorder, it also rotates. So all these are in rotatory motion. So these are examples of rotatory motion. So C is the correct answer, rotatory motion. Next, fifth one. Which of the following is not an oscillatory motion? A. Motion of the hammer of an electric bell, motion of your hands while running, motion of a child on a seesaw, motion of a horse pulling a cart. So in these, which is not oscillatory motion? So you can see hammer of an electric bell, it is in oscillatory motion. It will be moving, it will making oscillations. Hands also same, oscillatory motion. Child on a seesaw, that is also oscillatory motion. Motion of horse pulling a cart, it is not an oscillatory motion. Okay, motion of horse pulling a cart is not an oscillatory motion. Okay. Sixth one, Arun completed a 100-meter race in 16 seconds, while Karthik finished it in 13 seconds. Who ran faster? Who ran faster? 100 meters. Arun completed 100-meter race in 16 seconds. Karthik 13 seconds. So who ran faster? Karthik. So he completed in 13 seconds only. So he ran faster. So Karthik ran faster. The same distance 100-meter race is completed in 13 seconds by Karthik in a short interval of time compared to 16 seconds as completed by Arun. So Karthik ran faster. Okay. Seventh one. 1. A train runs from New Delhi to Hyderabad. It covers first distance of 420 kilometers in 7 hours and next distance of 360 kilometers in 6 hours. Okay, first 420 kilometers in 7 hours and 360 kilometers in 6 hours. Second one, Gopi takes part in a car race. He drives a distance of 70 kilometers each in the first, second and third hours. So in 3 hours. So in each hour he covered 70 kilometers. Okay. So 3 hours same. First hour, second hour, third hour. 70 kilometers he travelled. In each hour 70 kilometers. Okay. Which of the following statements is true? 1 is an example of uniform motion and 2 is an example of non-uniform motion. So uniform motion means it has to travel same distance in each hour. Okay. So here you can see 420 kilometers in 7 hours and 6 hours 360 kilometers. So it is not uniform. Okay. And second one 70 kilometers in first, second and third hours. So in 3 hours 70 kilometers, 70 kilometers, 70 kilometers he travels. So uniform. This is uniform. So is an example of uniform motion and 2 is an example of non-uniform motion. This statement is false. This is not true. Okay. Next, B. 1 is an example of non-uniform motion and 2 is an example of uniform motion. Yes, this statement is correct. Already we have seen. First one is non-uniform. Okay, 7 hours, 6 hours and distance travel is also different. And here in each hour he travelled 70 kilometers. So this is uniform motion. So this B statement is true. 1 and 2 are examples of uniform motion. False. 1 and 2 are examples of non-uniform motion. This is also false. So B statement is true. Okay. Now let us see 8th one. Write the motion of different parts of bicycle while it is in motion. The wheel, the cycle chain, the pedal with its arm, the movement of the feet pedaling, the movement of the rider along with the bicycle. So first one, the wheel, it is in rotatory motion. The cycle chain, that is also in rotatory motion. The pedal with its arm, that is also rotatory motion. The movement of the feet pedaling, that is oscillatory motion. The movement of the rider along with the bicycle, translatory motion. Okay. Next, 9th one. Which of the following statements is correct? A. The basic unit of time is second. Every object's motion is uniform. 2 cars move for 5 minutes and 2 minutes respectively. The second car is faster because it takes less time. The speed of the car is expressed in kilometers per hour. Okay, first one is the basic unit of the time is second. Okay, the time units of time is seconds. So this is correct statement. Okay, the statement is correct. Every object's motion is uniform. So this statement is not correct because each object is of different motion. Okay, it may be uniform or not uniform. Okay, so non-uniform, it may be uniform or non-uniform. So this statement is false, not correct. two cars move for 5 minutes and 2 minutes respectively. The second car is faster because it takes less time. This statement is not correct because here only the time is mentioned. Okay, one car is moving for 5 minutes, other car is moving for 2 minutes, but the distance travel is not mentioned. So when the distance is mentioned, then only we can say which one is faster. So this statement is not correct. The speed of a car is expressed in kilometers per hour. Okay, this statement is correct. Generally the speed is nothing but distance traveled per time. So kilometers per hour. This statement is correct. Next one, 10th. The basic unit of speed in SI system is kilometers per minute, meters per minute, kilometers per hour, meters per second. Okay, SI system, the basic unit of speed is meters per second. 11th one, the correct relation between speed, distance and time is, already we know speed is nothing but distance traveled by time taken. So which statement is correct in this? C, speed equals to distance by time. Okay. 12th one, the distance between two stations is 240 kilometers. A train takes 4 hours to cover this distance. Calculate the speed of the train. Already distance is given 240 kilometers and the time taken to travel this 240 kilometers is 4 hours. So speed is nothing but distance traveled by time taken. So 240 by 4, that is nothing but 60 kilometers per hour. Next, 13th one. A train travels at a speed of 180 kilometers per hour. How far will it travel in 4 hours? So speed is given here 180 kilometers per hour and time is 4 hours. Already we know the relation. Okay, speed is nothing but distance traveled by time taken. Here you have to find distance traveled. So distance traveled is nothing but time into speed. Okay, speed into time, that is nothing but 180 kilometers per hour into 4 hours, which is nothing but 720 kilometers. Okay. Next one, 14th. When do you say an object is in rotatory motion? Answer, motion of all particles of a moving object follow a circular path with respect to a fixed center of axis of rotation. Okay. Next, then the motion of the object is said to be in rotatory motion. Okay. So all the particles will be in circular path. When they are moving in circular path, that is nothing but rotatory motion. Next, 15th one. 15th one. Can an object possess translatory and rotatory motions at the same time? Give an example. Answer, an object can possess both translatory and rotatory motions at the same time. The wheel of a cycle during movement will have both rotatory and translatory motions. The wheels rotate, rotatory motion, and at the same time moves forward, translatory motion. Okay. Next, 16th one. Make a collection of action pictures showing living and non-living things in motion. Paste them neatly in a scrapbook. Under each picture, write the type of motion the picture shows. So this you have to do by your own. Here I have given some examples. You can see clock, rotatory motion, cradle, oscillatory, butterfly, curved, rabbit, linear. Okay. Next, 17th one. Collect the information regarding instrument used to calculate time in ancient days. So in ancient days, what are the instruments used to calculate the time? Just you have to collect the information about them. Okay, here I have given examples: sundial, sand clock or hourglass. Okay, these are the examples. Okay, by this we complete the 4th lesson of science, 7th class science. So In next video, we'll see the next lesson question answers. Till then, bye kids. Have a nice day.